Welcome back. We're going to continue with our next question on electromagnetism. So let's read the question first. It's from trial 2013, paper 3, section B, question 4, electromagnetism. Okay. Diagram 4.1 and 4.2 show a moving coil ammeter. The magnitude of current in diagram 4.1 is lower than in diagram 4.2. Okay, so when we want to compare the the two diagrams, we can find that the manipulated variable is actually current, and the responding variable is based on these two scale here. So we can see that the deflection of ammeter needle is different due to different current supply. Okay, so what we want to investigate here actually, so basically this is effect of force on a current carrying conductor in magnetic field. So this is the longer title for this experiment, but actually it's just motor effect. So it's just the factors that determine the strength of the rotation of the motor. Okay, so observe the deflection of the pointer. Okay, so you're going to change the deflection of pointer instead of ammeter, deflection of pointer in both diagrams based on the information and observations. State one suitable inference and one suitable hypothesis. So we're going to write it in our answering template. Make sure that you're able to build one big table using ruler. Okay. Inference. The deflection of pointer is depends on the current or the magnitude of current. So hypothesis, the higher the current or magnitude of current, the larger the deflection of needle pointer. Okay. So before we going through the aim and others, let's see what's the question give us in for. So basically, the question asks us to use apparatus such as DC power supply, ammeter, C-shaped steel yoke, bare copper rod, and other apparatus. Basically, they give us 4 already. So minimum is 5 functional. But in this type of experiment, there are a lot of apparatus need to be included in order to make it functional. So we cannot limit ourselves to 5 anymore. We have to include all functional. Okay, basically you give us a lot here. So make sure that you list that first before you list the extra, the other apparatus that need to be functional. So describe an experiment to investigate the hypothesis. So basically the aim to investigate the relationship between the current and the force. So basically the deflection of the pointer is represented by the force, the magnitude of the force. But we don't measure force here, we measure it differently in this experiment. So manipulated variable, make sure that you write it in a complete sentence. Current corresponding variable displacement. That is how we're gonna measure the force, or you can just state the force here, doesn't matter. But we're gonna measure the displacement instead of force in terms of Newton. We measure it in terms of meter, which is, or centimeter, which is more easier. CV here is the strength of magnet. Okay. So list of apparatus and materials. So first DC power supply, ammeter, C-shape, steel, what's this the correct term here? Let's see again. C-shape steel yoke. C-shape steel yoke, back of the rock. C-shape steel yoke. Steel yoke. Back copper rod. Next, we have to add more connecting wires. Switch. We'll start to adjust the current. What else? Thick copper wire and also magnets. Two magnets. Oh yeah, suitable to measure the displacement. Okay. So the arrangement of apparatus is quite a bit complicated, but actually you can still manage to draw. First, we have the C shape steel here, and then this the north is make sure that you draw it properly using ruler. Here I draw it free-handedly, so it look like terrible drawing, but you have to draw it using ruler. And then you put the thick copper wire here and the bare copper rod here. So make sure that you draw it clearly. And then we connect the thick copper wire with a DC power supply. Ammeter and rheostat. Press switch. Okay. So let's label C-shape steel yoke. Another magnet. So here, and then copper rod. These two here is thick copper wire. rest you can either label it or not because we already know the symbol what's it mean. So this is dry cell or the DC power supply. So DC power supply. Standard symbols. This is the switch, rheostat, and ammeter. Okay. Experimental procedure. Number 1. Set up the apparatus as shown on diagram. Number 2. Close the switch. Close the switch and adjust the rheostat. I spell the rheostat already here. So adjust, we have to adjust the rheostat to I equal to 0.5 ampere first. Number 3, record the displacement of the copper rod using meter rule. Make sure that you stated the measuring instrument. Number 4, repeat the experiment using I equal to 1.0, 1.5, 2.0, and 2.5 ampere. So basically you cannot go higher than 3 or 4 because we use DC power supply, which is quite limited in terms of the current. So you have to use small but attainable in terms of the result. But again, you can just replace the values I here with A, B, C, D, E or W, V, W, X, Y, Z. It doesn't matter actually. Okay. The tabulation of data. So make sure that you draw the table like always using ruler. This is the current ampere. This is the displacement centimeter or meter. So we have 5 data. 0.5, 1.0, 1.5, 2.0, 2.5, minimum 5 data. Next, we draw the axis. Draw it very nicely using ruler. Make sure that you give it axis title and correct unit. So this is the manipulated variable. The unit is ampere. This is the displacement. The unit is centimeter. Okay, I think that's all for today. But before we end our video, let's check what other experiments that share the same experimental setup. So basically, the factors that we going to investigate for number 1, other than the before is current, the other is strength of magnetic field. The other number 2 is diameter of copper rod. or length of copper rod. Okay. So I think that's all for today. Make sure that you know the differences between the induced current experiment, the motor effect experiment, or the strength of electromagnetic experiment. So we're gonna answer all three types of question, but let's go through one by one and make sure that you understand how to set up the experiment and how to recognize the factors, the manipulated variable, the responding variable, and the constant variable. Okay, that's all from me today. Thank you.